This is the Math 2 lesson summary video for Is It Right? In Lesson 2, Is It Right?, the students solidified their understanding of what it means for two lines to be perpendicular. In the task, the students experimented with a right triangle in the coordinate plane. The students performed a 90-degree rotation on the triangle and investigated the relationship between the line segments of the pre-image and the corresponding segments of the image. By the end of this task, you should be able to define perpendicular, determine if two lines are perpendicular using the slopes of the lines, and determine if two lines are perpendicular using the angles formed at the intersection of the lines. Yesterday, when we reflected in Let's Get Away Lizard, we referenced the fact that horizontal and vertical lines are perpendicular. In our first example, we have the horizontal line y equals 2 and the vertical line x equals 3. We could use a protractor to measure to discover that this intersection creates 4 right angles. 1, 2, 3, 4. So we can further define perpendicular lines as lines that intersect to form 4 adjacent right angles. What if a line or line segment is not horizontal or vertical, and the lines do not intersect to form 4 congruent adjacent angles? How can we use the slope of the line or line segments to know if the line segments are perpendicular? In the following 4 experiments, we will consider points A and B and the line segment AB between them. We will locate a third point, C, that will form a right triangle, and we will justify how we know that this third point, C, will create a right triangle. We will then rotate the right triangle 90 degrees around a point in the coordinate plane and justify how we know that the triangle was rotated 90 degrees. Finally, we'll compare the slope of the hypotenuse of the rotated triangle with the slope of the hypotenuse of the original triangle. Based on these experiments, we will be able to make an observation about the slopes of perpendicular lines. In Experiment 1, points A and B have already been plotted, as well as the line segment AB between them. To find the slope of the line segment, we can use rise over run. We will rise 4, run 2. The slope of line segment AB is 2. Now we're going to locate a third point, C, on the coordinate plane so that A, B, and C form the vertices of a right triangle with AB as its hypotenuse. So if we trace where we counted rise over run, rise 4, run 2, we can find point C such that a right triangle is formed. We could have also started at point A and run 2, followed by rise 4. This gives us another possible option for point C. Point C could be located at 2, 7, or at point 4, 3. We know that triangle ABC is a right triangle. If we had selected C at 2, 7, segment BC is horizontal and segment AC is vertical. Since one leg is horizontal and one leg is vertical, we know that triangle ABC is a right triangle. If we had selected 4, 3 as point C, segment AC is horizontal and segment BC is vertical. So the triangle has one horizontal leg and one vertical leg, so triangle ABC is a right triangle. For our experiment, we will use the ordered pair 2, 7 for C. In part 4, we are asked to rotate triangle ABC 90 degrees about vertex point 2, 3, which is point A. We will use patty paper to help us perform the rotation. Since 2, 3 is the center of rotation, we will fix point A and rotate 90 degrees counterclockwise. We'll label our new image as triangle A', B', C'. We know that we rotated the triangle 90 degrees because the segments that were originally horizontal on the pre-image are now vertical on the image. Segment AC, which was vertical on the pre-image, is now horizontal on the image. We can also compare the slopes of the hypotenuse for the pre-image and the slope for the hypotenuse of the image. If we look at the slope of the hypotenuse for the pre-image, which we looked at in part 1, we know that the slope is 2. If we find the slope for A', B', we see that the slope is rise, -2, run, 4. So the slope of A', B' is -1/2. Since the slope of A', B' is the opposite reciprocal of the slope of segment AB, we know that segment A', B' and segment AB are perpendicular. Let's take a look at experiment 4. We're going to repeat the steps that we did in experiment 1 for the points A at 2, 3 and B at 0, 6. The slope of AB we can find by doing rise over run. So rise, -3, run 2. We can find point C using the path that we traced for rise over run. C could be located at 0, 3, or if we started at point A and rose 3 and went to the left 2, we could find point C could also be at 2, 6. We will use the point 0, 3 in our experiment. We know that triangle ABC is a right triangle because leg BC is vertical and leg AC is horizontal, forming a right angle at angle C. We are now going to rotate triangle ABC 90 degrees around the ordered pair 2, 3, which is point A. We know that the triangle was rotated 90 degrees since segment BC was vertical and segment B', C' is now horizontal. And likewise, segment AC was horizontal, and segment A prime C prime is now vertical. We can compare the slopes of the hypotenuse of the original triangle to the hypotenuse of the image that was formed. The slope of AB was -3/2. Using rise over run, we can find the slope of segment A prime B prime. Rise 2, run 3. It's 2/3. We know that segment AB and segment A prime B prime are perpendicular because the slopes are opposite reciprocals. We can verify that the slopes are opposite reciprocals by finding the product of the slopes. Since the product of -3/2 and 2/3 is -1, we know that the two segments are perpendicular. In this task, we discovered that the slopes of perpendicular lines are opposite reciprocals. This was evident in each of the 4 experiments. Here we have the slope of the original line segment, and here we have the slope of the image line segment. It is evident that the slope became the opposite reciprocal. The product of the slope of segment AB and the slope of segment A prime B prime is -1 in each experiment. Additionally, you can see that the rise over the run switched places, and one of them became the opposite. For example, in experiment 3, the slope of segment AB was 2/5. Rise 2, run 5. The slope of the image segment A prime B prime was -5/2. The rise became 5 and the run became 2, and we had to move the opposite direction. We only moved the opposite direction for either the rise or the run. This concludes Lesson 2, Is It Right? During this task, you should have been able to solidify your understanding of what it means for 2 lines to be perpendicular. 2 lines are perpendicular if they meet to form congruent adjacent angles, and 2 lines are perpendicular if the slopes of the lines are opposite reciprocals. If you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.